The San Andreas Fault, California's sleeping giant. The San Andreas Fault stretches 800 miles across California, creating one of the most dangerous geological features on Earth. This massive crack in the landscape runs from the seabed near Point Arena in Northern California down to the Salton Sea in the south. The fault's destructive power became clear on April 18, 1906, when San Francisco was devastated by a magnitude 7.8 earthquake. The ground shook violently for 45 seconds, followed by fires that raged for 4 days. More than 28,000 buildings were destroyed, and over 3,000 people died. Scientists discovered that the San Andreas Fault marks the boundary between two massive pieces of the Earth's crust: the Pacific Plate and the North American Plate. These plates have been grinding past each other for 20 million years, moving at about 1 inch per year. The Pacific Plate carries Los Angeles northwest toward San Francisco at this steady pace. Today, scientists closely monitor the fault using GPS equipment and seismographs. They've identified areas where stress is building up, particularly in Southern California, where no major earthquake has occurred for over 300 years. Computer models suggest that when the next big one hits, it could cause thousands of deaths and billions of dollars in damage. The investigation revealed that some sections of the fault move smoothly without major earthquakes, thanks to soft, slippery minerals like talc that act as natural lubricants. However, other sections remain locked, building up dangerous levels of stress that will eventually be released in devastating earthquakes. The Mariana Trench, Earth's deepest mystery. Hidden beneath the Pacific Ocean lies the Mariana Trench, the deepest point on Earth. This underwater canyon plunges nearly 7 miles below the surface, deeper than Mount Everest is tall. The trench was first discovered in 1872 by the HMS Challenger expedition, which used ropes and lead weights to measure ocean depths. Modern sonar mapping revealed the trench's true scale: 1,500 miles long and shaped like a crescent moon. In 1960, two brave explorers, Don Walsh and Jacques Piccard, descended to the bottom in a submersible called the Trieste. They endured crushing pressure equivalent to 50 jumbo jets pressing down on them from all sides. At the deepest point, they were surprised to discover life thriving in this extreme environment. The trench formed through a process called subduction, where the heavy Pacific Plate slides beneath the lighter Philippine Plate. As the descending plate bends downward, it creates the deep trench. The plate continues sinking into the Earth's hot interior, where it melts and creates magma that rises to form the volcanic Mariana Islands. Scientists discovered that the ocean floor at the Mariana Trench is 170 million years old, the oldest on Earth. This ancient crust has become extremely dense and heavy over time, causing it to sink deeper than any other ocean floor. The trench acts like a giant recycling plant, consuming old ocean crust at a rate of 3 inches per year. Krakatoa, the volcano that shook the world. In 1883, the Indonesian volcano Krakatoa exploded with such force that it was heard 2,000 miles away. The eruption was the loudest sound in recorded history, equivalent to 200 megatons of TNT, 13,000 times more powerful than the atomic bomb dropped on Hiroshima. Before the eruption, Krakatoa was a peaceful island with 3 volcanic peaks covered in lush vegetation. Warning signs began in May 1883 with earthquakes and small explosions. But these were just previews of the catastrophe to come. The main eruption lasted over 20 hours, sending ash clouds 17 miles into the sky. The explosion was so powerful that it blew the entire island apart, creating a massive crater called a caldera. The collapse triggered enormous tsunamis that reached heights of 130 feet and killed more than 36,000 people across Java and Sumatra. Scientists studying the eruption discovered that Krakatoa was a stratovolcano, the most dangerous type. These volcanoes produce thick, sticky lava filled with explosive gases. When two different types of magma mixed inside Krakatoa's chamber, it created the perfect conditions for the massive explosion. Today, a new volcano called Anak Krakatau, child of Krakatoa, is growing in the exact spot where the original island once stood. This young volcano is one of the fastest growing on Earth, rising about 12 feet per year. Scientists monitor it closely as it could potentially become as dangerous as its parent. New York City, built on ancient mountains. Beneath New York City's towering skyscrapers lies a foundation of rock that tells an incredible story spanning 450 million years. The bedrock, called Manhattan schist, was formed under enormous pressure when ancient continents collided to create massive mountain ranges as tall as the Alps. These ancient mountains have long since eroded away, but their roots remain as the hard bedrock that supports the city's famous skyline. The distinctive pattern of New York's skyscrapers, clustered in downtown and midtown Manhattan, follows the underground landscape of this bedrock. Where the rock is close to the surface, tall buildings can be anchored directly into it. Where it dips down and is covered by softer sediments, building tall structures is much more difficult. The city's journey to the coast began 200 million years ago when massive volcanic eruptions tore the supercontinent Pangaea apart. These eruptions, preserved today as the Palisades Cliffs along the Hudson River, marked the birth of the Atlantic Ocean. As the continents separated, the area that would become New York found itself on the eastern shore of North America. During the last ice age, glaciers over a mile thick covered the region. These massive ice sheets carved out the Hudson River Valley and left behind the deep harbor that would make New York one of the world's greatest ports. When the ice melted 16,000 years ago, a catastrophic flood broke through natural dams and carved out the Narrows, creating the entrance to New York Harbor. Loch Ness. Scotland's ancient lake Loch Ness, famous for its legendary monster, holds more water than any other lake in Britain. At 23 miles long, over a mile wide, and 750 feet deep, this massive freshwater lake has a fascinating geological history that spans billions of years. The story begins with some of the oldest rocks on Earth, 3-billion-year-old formations that make up the bedrock beneath the lake. These ancient rocks formed during the early days of our planet, when the first solid crust was cooling on Earth's surface. The straight-line shape of Loch Ness follows the Great Glen Fault, a massive crack in the Earth's crust formed 450 million years ago when Scotland and North America crashed into England and Wales. This continental collision created mountain ranges higher than the Himalayas and left behind a zone of weakness that would eventually become the foundation for Loch Ness. Surprisingly, Scotland was once part of North America. Identical rocks found in both Scotland and New York prove that these now distant lands were once joined together. The separation began 60 million years ago with massive volcanic eruptions that eventually opened up the Atlantic Ocean, tearing Scotland away from America. The final shaping of Loch Ness occurred during the last ice age, when glaciers over 2,000 feet thick flowed down the valley. These glaciers carved out the lake's characteristic U-shaped profile, with steep sides and a flat bottom. When the ice melted 10,000 years ago, a natural dam of rock debris blocked the valley's outlet, allowing the lake to fill with fresh water. As for the Loch Ness monster, geology provides a clear answer. The lake is far too young to harbor any surviving dinosaurs. The dinosaurs died out 65 million years ago, while Loch Ness is only 10,000 years old. The forces that shape our world. These geological investigations reveal the incredible forces that have shaped our planet over billions of years. Plate tectonics. The movement of massive sections of Earth's crust drives mountain building, creates ocean basins, triggers earthquakes, and fuels volcanic eruptions. The Earth's surface is constantly changing, though usually too slowly for us to notice. Continents drift across the globe, mountains rise and erode away, and new ocean floor is created while old crust is recycled back into the planet's interior. Understanding these processes helps scientists predict future geological hazards and explains how our dynamic planet continues to evolve. From California's earthquake-prone faults to Indonesia's explosive volcanoes, from the crushing depths of ocean trenches to the towering peaks of ancient mountains, Earth's geology tells the story of a planet in constant motion. These forces that created our world's most dramatic landscapes continue to work today, ensuring that Earth will keep changing for billions of years to come. The evidence lies all around us, in the rocks beneath our feet, the shape of our coastlines, and the patterns of earthquakes and volcanic eruptions. By reading these geological clues, scientists can unlock the secrets of Earth's past and better prepare for its unpredictable future.